Hey folks, so this video is just going to be a quick introduction to vectors for our physics. We're going to use a lot of different vectors as we go forth through physics content. Things like displacement, velocity, acceleration, momentum, all these are vector quantities. So we're going to try and figure out what is a vector, why does it matter, how do we do some mathematical operations with them like adding or subtracting vectors. So we're going to get into that. Now this is all stuff that if you watch the Introduction to Vectors video or you read the PDF on vectors from cracking the AP Physics 1 exam or cracking the AP Physics C exam, all of those are covering the same content, but I'm just going to go through it here in this video. So one of the important things for vectors is that there's a difference between a vector and something else called a scalar. So any quantity or value that we come across in physics, it's either going to be a vector quantity or a scalar quantity. And we need to differentiate between those. So the difference being a vector and a scalar both have magnitude. Magnitude just being a number or how big or how much of something we have. So we could use a value like 3 miles. 3 miles is a magnitude. It tells you how much, how far in this case. So a scalar or a vector, both of them have magnitude. The difference is a vector will always have a direction. Whenever we talk about vector quantities in physics, we care about which direction it's going, whether that's what direction is it going for velocity, how fast is it going, what direction is it accelerating, speeding up, slowing down, what direction is the momentum of an object directed. So we always care about direction for vectors. So if I say 3 miles north, then it becomes a vector instead of a scalar. A scalar value only has magnitude, something like 3 miles. A vector value has magnitude and direction, so 3 miles north. Now, for drawing or showing these vectors, we're generally just going to use an arrow, and I'm going to use the good old Cartesian coordinate system. So this is our XY plane that I'm sure you've seen many times in your math classes. So I'm going to start down here on the x-axis. And if I wanted to draw 3 miles north, I'm going to say each tick mark is a mile, and I'm going to go 1, 2, 3. So that arrow would represent the vector 3 miles north. And I'm going to label it, I'm going to call it vector A. Sometimes the textbooks in physics will have like a bold capital letter for a vector. The easiest way for us to indicate it, especially if I'm doing something on a board or you're writing on a piece of paper, we can't really bold something. So we're going to draw a little arrow over the top of it. And that arrow tells me that it's a vector. So this is our vector A, 3 miles north. So we're going to get into how to add two vectors together. So if I have this vector A that's going 3 miles north, and then I'm going to make a vector B. And we're just going to say this vector B is 2 miles east. So if I do a couple tick marks here. Okay, so if this was our starting point right here, we know that our vector A goes 3 miles north. Now we want to add onto it another vector B that goes 2 miles to the east. So if I were to just draw it on the x-axis, it would look something like, starting from this point, it would go about to here. So that would be our vector B. From our starting point, we're going about 2 miles to the east. Now, whenever we're adding vectors together, the easiest way to do it and to find what we call a resultant vector is to start from the tip of the first vector. So this is the tail, what we call the tail of A, tail of the vector, and then the tip up here. So we're going to go from the tip to the tail of, or the tail to the tip of A. Then we start at the tip of this vector, and we're going to add on this vector B. So there we go. So now we've added the vector B onto A. So we went 3 miles north, then we went 2 miles east, and what we call our resultant vector, which we'll call C, we start from the very beginning. So the tail of A, then we go to the very end of our vectors, so all the way to the tip of B. Well, that kind of works. And that's going to be our vector. We'll call it C. And in this case, the vector C is equal to just adding together A plus B. So whenever we add visually or graphically, we're going to take those arrows and go tail to tip, and then start the next one right there, tail to tip. If we had 3 vectors, you could just keep going, add another one on, tail to tip. So you can add any number of vectors, and then once you get to the very end of that last vector, you go from your starting point to your final ending point, and that's your resultant vector. So we'll talk more about how to break this down into what we call vector components and how that works. But for now, we know that vector C means that we went 3 miles north, then 2 miles east. So that's adding vectors. Now, you can multiply vectors by a scalar. So if we had A, we know that A is 3 miles north. We could take this vector A and multiply it by a scalar. So let's say we want to double it, or maybe we want to triple it. So we could say 3 times the vector A, and the math here is pretty straightforward. Whenever you take a vector and you multiply it by a scalar, you just take, another way to write this is you take this scalar, which in our case is 3, times the magnitude of the vector, which is 3 miles. And then in our case, we're going to end up going in the same direction north. The only way this would change is if we multiplied our vector A by a negative number. So in this case, we'll end up, if we just do 3 times A, or triple our original vector, we would end up with 9 miles north. If we had, for example, a negative 3, what we would end up with is the negative of this vector, and also tripling it, would be 9 miles south. And you can sort of see that here, because if we mathematically go through here, we've still got a negative sign. So we would end up with negative 9 miles north. And another way to say negative 9 miles north would be 9 miles south. So if you multiply a vector by a negative scalar, you just need to switch the direction. If you multiply a vector by a positive scalar, then you keep the same direction. All right. So subtracting vectors. Now we know that our vector B is here, and it's a positive 2 miles to the east. But what if we wanted to do A minus B? The easiest way to do A minus B is actually to just figure out what's the opposite of B, or negative B. And another way to write this, we can do A plus whatever our negative B is. A plus the opposite of B. So if we go the opposite of B, instead of east, we're going west. So 2 miles west, it would look something like this. So this would be our negative B. So the easiest way to subtract vectors is just to add on the negative. So first we want to figure out, okay, what's the opposite of B, or the negative of that vector? We could draw it or visually see it on the graph, and then we're just going to add that on. So obviously our resultant vector C in this case would look different. Instead of going northeast, we're going to end up going northwest. So the trick to subtracting vectors is that we're just going to want to find the opposite of this vector. Instead of trying to do just A minus B, find what negative B is, and then add that on to A. Because visually that's easier to draw on vectors. And what that allows us to do, the reason we do this is that then on the graph, or visually, we can do the same process of tail to tip, tail to tip. Because now we're taking negative B and adding it on to A. And by adding it on, we just say, all right, we're going to add negative B onto A, tail to tip, tail to tip. It's straightforward. This would be a little more challenging, because what you'd have to, well, not challenging, but it would look strange, because what you'd have to do if you just did A minus B, you'd have to, instead of going tail to tip, you would actually go, if you would take this and move it over here, but the tail would be here and the tip would be there. So it looks really weird visually when you try to do that. So the easiest way to do this on our graph, as we have it here, is to find what the opposite of B is and just add that onto A. So the other thing that we should go over real quick is unit vectors. So I'm going to erase all of this stuff. Now unit vectors, we're going to use the same Cartesian XY coordinate system. There's a Y, there's an X. So a unit vector is a way of having like a base unit to describe going in the X direction or going in the Y direction. So if we have, this is 1 and 1. So if we go 1 unit in the Y direction or 1 unit in the X direction, these are our, what we call our unit vectors. So here's 1 in the X direction, 1 in the Y direction. And typically the way that we symbolize these is for Y, we use the letter J. And then because it's a vector, I usually put a little like arrow hat over it. So in my physics, in college, they would always call this J hat because it looks like it has a little hat. So J with a hat on, and then the X direction one is I with a little hat on it. So J hat and I hat are the unit vectors, which means they always have a value of 1. So if you were going 1 unit in the X direction or 1 unit in the Y direction, that would be your unit vector. And the reason we use unit vectors is, let's go back to our, I'm going to use a different color. Let's go back to our vector C. So we had a vector C that was going, I'm going to start from the origin this time, but something like this. It's going northeast. So in this case, we're going to want to be able to break this vector into some components. And what we mean by components is we're going to talk about what's going on in the Y direction for this vector, the J hat, what's going on in the X direction, or the I hat, for this vector. And in order to do that, we knew that our vector C, we went 3 miles, or 3 units north, and then we went 2 units to the east. So in terms of our new units J and I, we can say we went 3 units in the positive Y direction, and we can use J hat for that. And then we went positive 2 units in the X direction, or to the east, which was our I hat. So unit vectors are a way to write any vector in terms of how far does it go in the Y direction, positive or negative, and how far does it go in the X direction, positive or negative. And any vector can be written in terms of some scalar, so we know that 3 is a scalar, 2 is a scalar, those are just numbers, just magnitude, so those scalars, and we multiply them by these, which are called our unit vectors. So no matter what vector you have, you can always break it apart into, these are called components. So this would be our Y component in the Y direction. This would be our X component in the X direction. So J hat and I hat help us just symbolize how far is this, or how big is this vector in the X direction, how big is this in the Y direction. Now you could even do this in 3 dimensions if you added on a 3rd dimension and wanted to go there, but we're going to stick with 2, just X and Y for the time being. I don't think we're going to get to do too much with 3 dimensions. All right, but that's unit vectors. So any vector, like let's say, even if you have one that's just going vertically, let's say we're going 4 units or 4 miles upwards, so we'll call this D. We could just say it's 4. And if you have actual units, you could put them in there, so 4 miles, 4 meters, whatever it is. But in the positive Y direction, we use that unit vector J hat. unit vectors are just a way to say any vector can be written by multiplying some scalar values times our unit vectors j hat and I hat to tell us how far is this going, or how big is this in the x direction, how big is this in the y direction. Okay, so we've been through unit vectors, what vectors are, what scalars are, how to add, how to subtract. There's some more things that we're going to go over with vectors in the future. So for now, that's kind of our initial snapshot. And again, hopefully this video was helpful, but it can also be really helpful to check out the video I posted for Intro to Vectors, as well as the PDF. And there's some more resources. I'm trying to get some more resources filled in on the resource tab. I have some crash course physics linked that I'm going to link up